Hello everyone. Am I audible?
Yes,
Yes, sir.
yes,
Okay,
sir.
thank you. So this is the week three session. Okay, so we'll be discussing about week three content, and if you have any doubts, you can ask. I hope everyone has installed PostgreSQL and loaded all the three databases, right?
Yes,
So
sir.
this
Yes,
is
sir.
what we have discussed in week two.
Sir, today you will be discussing the concepts, right?
Week three. So in week three, we have joins, right? So joint party ceremony, I guess in the previous session, week two content is discussed, how to create the tables, right? The concept of primary key, all the constraint, all the data types, right?
Yes, sir.
Yes.
Yeah. So joins is ceremony. So we'll discuss that in today's session. In week two, we have few tutorials like SQL code execution. So you can go through that. I have discussed what professor has taught in the slides. So I have executed it with the admin. So you can just follow that for week two. Okay. In week three, we have this joins. I will discuss it today. And in last module, not module, last lecture, we have triggers and procedures. For that also, we have a tutorial. So please go through that tutorial as well. Okay, fine. So let's okay. So let's start the session. Let me share my screen. Is my PG admin screen visible?
Yes. Yes, sir.
Yes, sir.
Okay, thank you. Okay, great. So I hope everyone is aware about how to get a data from a database. So this is basically LIS. You can see on the left side, I have loaded the LIS DB. You can see a schema, and then if you scroll down on the left side, you can see a tables. So we have 10 tables in LIS database, right? And if you want to see a schema diagram, so you can refer to uh, that PostgreSQL resources folder. But if you want to generate a ER diagram from this, you can do that. Just simply right click on database name. You can see EID for database. So here you can see database, tables and the relation between the tables, right? So you can see here like that. So let's say, for example, I have a student table, right? So we'll revise few week two concept here. So let's say, for example, I want to view a data from a student table. So can anyone tell me what's the query for that? If I want to view all the data of students table,
Select star from students.
yeah, select star from students here, right? So select star. Star means what? If you want all the columns in from that particular table, we have to mention this asterisk symbol here. Otherwise, if you just want a specific column, you have to mention the names of those specific columns. That's it, right? So you can see here, if I execute this query, you can see the output below here, right? Student name, all the columns we are getting, and all the rows you can see we have 52 rows here, right? Now let's say, for example, I want to filter the output here. So once I got the data, I want to filter the output. Now I just want information of a student from CS department. You can see a department code CS, ME, EE we have, right? So how we can get that if I just want the information of a department code CS? Yes, anyone?
Sir,
Using where clause.
Yeah.
where department code please admin.
Yes. So where department code equals to what CS here, you can see, right? So this is how we can filter the output here. So where clause is used for a filtering purpose, we can apply many condition using and or clause here, right? So here you can see if I execute this one, you can see I am getting information from a CS department only, right? So here we have a gender, male and female. If I just want the male student record, I can put one more condition, gender equals to M here, right? So this is how we can get a data from a table, how we can apply a condition to filter the record here. I hope this thing is clear, right? Now, let's say, for example, I want information of CS and ME department code, both the codes here. If you observe, we have ME department as well. So how we can get that CS and ME both?
Using OR clause.
or union.
Okay, so where department underscore code equals to what? CS. Okay, after this,
sir.
yes.
Sir, when I was trying to do a query in pgadmin, some of my keywords are not working properly. How can I resolve it?
The keywords are not working, so whatever you are typing, that is not getting executed here, right?
Yes, sir.
You have to select the query and then you have to execute the button. I guess you are simply executing without selecting the query. Can you try that?
No, sir. It's still giving me error.
Okay, after the session, you can share your screen. You can let me know. Okay.
Okay, sir.
So here, if I want information about CS and ME department, how we can do that? Yes, anyone?
And clause also you can use, sir.
Sir, OR clause.
No. No. See, if I put and here and department code equals to CS, so how the query works, right? Here you can see where department code equals to CS and department code equals to ME. If I put like that, so it will try to match for that particular tuple. So department code CS true and department code ME false. So true and false will give me false. So we cannot apply two conditions on the same field here, right? Department code CS and department code ME cannot be true at the same time, right?
Yes, sir. Yes, sir.
Department code in CS and ME.
Sir, we can use in
OR, sir. CS code or department code ME.
Yeah, so we'll discuss about the in and not in clause here. So we can use or statement like that, or department code equals to ME. This is correct. Okay, again we have to put that thing, department code equals to ME. If I execute this one, you can see here we'll get both the information, right? So this is fine. If we want to apply CS, ME, MCA department, we can put or condition. But how many times we are going to put like this, right? Let's say, for example, I have 20 departments in my university and I want to fetch a data of 10 department. So shall I keep mentioning this 10 times? No. What we are going to do, we are going to use in clause here. Now, how in will work? Let's see. So here I need to specify on. So first we need to put the attribute on which you want to specify the condition. So department code in ME, comma, CS. So how this will execute? It will try to check department code equals to ME or department code equals to CS or whatever you are going to mention inside this bracket, it will try to match with that particular record. Even if it is not present, let's say for example, I am putting like this, anything. But anyway, this is not going to get executed. But for this one, it will get executed, right? So even it will try to match with any at least one, we can say, field. So it will give us the output. So simply it is equivalent to, we can say, department code in, then ME, comma, CS, like that we can have. So if I execute this one, you can see we are getting the output here. Anyone, any doubt what we have discussed now about the in clause here?
No, sir.
Sir, when we apply the condition, two conditions simultaneously with using or, then the condition using first filter them by the order or directly fetch the data. Like when we use the condition department code is equals to CS or department code equals to ME, then the code firstly fetch about the CS and after that ME, or they directly fetch the data.
Okay, so see, this is basically a set. So output of any SQL query is set here. So there is no fixed order. Even if I execute this time, so the output will be in the random order, right? So output of SQL is basically a set here. In set, we don't have any order, right? And the question you ask, like if we have multiple statement, let's say for example, department code equals to ME or department code equals to CS and gender equals to M. So if we have this or and multiple kind of things here, so this will work according to the precedence of and or. So first and will execute and then or will execute like that. Okay. If we don't put the bracket in the condition, otherwise first bracket will execute, then and then or will execute like that.
Okay, sir. Thank you, sir.
So you can try one thing. First department code equals to ME, then or department code equals to CS and gender equals to M, and then The second query, you can try gender equals to em and department code equals to me, or department code equals to CS. You can see a different output in both the case. Okay, like that. But remember one thing: the output of SQL query is always a set. Okay.
Okay, sir.
Yeah. So this is about what we're discussing. Yeah, in clause, correct? Yeah. So let's say, for example, here we have discussed about in, but I don't want the output of CS and ME department. I want the information of all the students apart from CS and ME. In that case, how we can get the data?
Not in.
Not in.
Yes, not in, right? So here, instead of in, we can simply put not in here. That's it, right? So this is how in and not in will work. Okay. So is this get covered in previous session in week 2? Have we discussed this in, not in? Okay, fine. So you can see the output here. So it's not like that we have to just put some fields here. We can also put the SQL query as well, right? If I say select, but we need to match with the department code here, right? So if you look at a different department here, where it is, yeah, we have a department table, right? So you can see here we have a department code also. So let me execute a department table. Also select star from departments. Yeah, you can see this code and these are the department name. Now, if I say I want all the students from the computer science and electrical engineering department name, right? So what I can do here, I will go with in, and if I don't know the department code, but I know the department name here, so first I will write this department code in, then I will put select department code from departments where department underscore name equals to what? Computer science. Here also we can use the in clause here like that. In computer science and electrical engineering. Let me take a new line here. Yeah. So what we have discussed here. So we can also write a SQL query inside the in statement here. So, but make sure that the attribute we have used here, that must we have to use. So you can select department code so that it can match with the department code in the output. Okay. So if you see in the previous thing, select star from student or from student table, we cannot apply condition on department name because department name is not present. Department code is present here. But if you want to apply condition on department name, so first we can get a department code from department table, and then we can fetch the record from a student table like that. So engineering like that. So if I execute this one, you can see the output. Okay, what happened?
Sir, brackets, sir, for in clause.
In clause, and here also we need to put one more bracket for this one. Yeah. Yeah, you can see the output here, right? So either you can specify the values or you can write the SQL query inside the in and not in here, right? That is what a subquery is here. This is about the subquery part. Okay. I hope this thing is clear about in and not in. Anyone, any doubt here? Okay. Now let's say, for example, I want to find out the detail of a student whose department building is block underscore 3. I want to find out detail of a student. How we can do that? Department building is block 3, block underscore 3.
Sir,
Yes.
sir, is it not required to put a semicolon at the end of our query in pgadmin?
No. In pgadmin it is not required. So it depends on the editor, right? So if you are using a terminal, then it is necessary. But here it is not required.
Do we need to use the in exams like are the graders?
No. In assignments also, in OP also, you don't need to use semicolon. We already put a note there in the assignment. Okay.
Okay.
So yeah, my question is, I want all the details of a student table from department building block underscore 3. How we can get that?
Sir, select from department building equal to block 3.
Select department.
Select star from department.
No, I want the
Sorry,
student
sorry.
information, right? Yeah. I want student information whose department building is block 3.
The subquery will select department code from departments where department building in
Yes.
department building equal to block 3 or in block.
Yeah. So you can see here, because if you look at the schema, right, the only way to fetch a data from student and department table combined is basically what this department code is common between both the table here. So we can join the tables using this common attribute here, right? So you can see here. So we need to either we can use like that or we can go with the join also. So we'll discuss join, but let me execute this one. So department building equals to block 3.
Sir, so which attribute is common? We need to link both of them to get the right answer, right?
Yes, yes, yeah.
Okay, okay.
What happened? Spelling is something. Okay, sorry.
Sir, can you explain this code? I am not getting.
Yeah. So our requirement is we want the information of a student who is from block 3 department building. Like building is basically block 3. So student information from block 3 you can see, right? So how we can get that? You can see a schema, right? So I hope this is visible, right? Yeah.
Yes, sir.
Yes.
So I have a student table from which I want data of all the students, but my condition is on the department building, that is block 3, this attribute. So it means what? I need to use both the tables to get the required information, right? But how we can join the tables, or how we can match the output from both the tables? So you can see this link here. So department code is common here. So department code is a key here, primary key here in department tables, and here you can see a foreign key, right? So using department code, we can join both the tables, or we can say merge both the tables using a subquery part based on the department code here. So you can see department code. So I want all the information from student table. So select star from student. I want to filter the output where department code in. I want to match with the department code of a student whose building is block 3. So now inside the in clause, I have put it select department code from departments where department building equals to block 3 here, right? Is this fine?
So we cannot write directly the department building is block 3.
No, because we're applying a condition on student table. In student table, we don't have any block department building, right?
Got it, sir. Got it. Sir, can you show once again?
Code or this one?
Code, sir. Code.
Yeah, you can see here, right? So here we have used in clause. There might be possibility that in the same block we have a different department, right? So we can have that as well. So that's why we have gone for in clause. But here you can see in every building we just have one department. So in this case we can also use for equal to sign also. This will also work, right? But what if we have 2-3 departments in the same block? In that case we have to go for an in clause here. Okay.
Okay, sir.
Yeah. Okay. So this is about what student and department table. Okay. So this is how we can get data from both the tables. But I don't want to do this thing. I want to join the tables. So how we can join the tables? Because if you see whatever you are going to get project here, that will be in the output here, right? Select star from student. I said all the information of a student here. But what if I want department name and the student first name, or let's say for example roll number? So if I just put here, let's say for example a roll number underscore roll number, right? So roll number, along with the roll number, I want department name also, not the code. What will happen if I run this query? Yes, anyone?
Roll number and department.
Only roll number and department name will be shown, sir.
But do we have department name in the student table? You can see.
No, sir. No, sir.
Get an error.
Yeah, you can see. department table, department name is not in the does not exist, right? So if I want both the information, then in that case this query will not work. So I need to go for a joining then. So let's discuss about different types of joins in SQL. I already have a tutorial. I don't think we have added on the portal, but you can check our this DBMS YouTube channel. You can see in the video section different joins I have explained. Okay, so you can just refer to that. Anyway, we are going to discuss it now also. So joins in SQL. Okay. Yes, anyone? How many different types of joins we have?
Inner, outer,
Outer join.
Left outer join.
Cross joins.
Outer join. Then we have inner join also, right?
Yes, inner join.
Then
Outer
we have
join.
outer join. In outer join, we have left, right, full, right? So we'll discuss after that. So first, we'll discuss about these three one. Now, how natural join will work? Yes, anyone?
process everything with everything.
No, cross is basically cross join here, right? About
It's the
natural.
tuple of everything with everything.
Select
Simple join function.
same column.
No, the column won't be repeated when
Yeah, that's the, we can say, a feature of that. But how it will perform joining operation?
it will look at the common attributes, and it will match the elements in those common attributes. If they in the common attributes, they'll match the rows which have the
Yes, values we can say. Okay. So you can see it will join automatically based on the common attribute. So if I perform a natural join between student and department table, the common attribute is what? Department underscore code. So we don't need to specify anything. We just need to write the query. So automatically database engine will perform a joining operation based on the common attribute. So let's say, for example, select from students natural join. So this is syntax for joining two tables. Select star table 1 natural join. You have to specify the keyword like that, and then table 2, that is basically a departments table here. So if I execute this one, I am going to get all the columns from both the department. So columns means what? You can see department code, first name, last name, roll number, you can see, and then here we have department name and department building. Okay, so how many columns we have? 1, 2, 3, 4, 5, 6, 7, 8, and 3 columns here. So total we have 11 column, but one column is common, so that is basically 10 column we will have in this output, right? You can see here. So this is syntax for natural join. Select star from student natural join department. That's it. So automatically it will join based on the common attribute here. Okay. Anyone, any doubt?
Sir, so the meaning is like it won't repeat the common attributes. Am I right, sir?
So if department code is common, so it will not repeat it. You can see only once will be there in the output.
That is the difference between cross join and natural join, sir.
No, cross join is different. We'll discuss that.
Okay, sir.
That's the difference between natural and inner join. Okay.
So, sir, will departments natural join students be equivalent to what we just did? Students natural join department.
Order will not matter if we have a 2 table. If we have 3 tables, then it may matter. Okay, but if we just join 2 tables, then it will not matter. And how we can join 3 tables? Simply you can just put natural join the third table. Third table is basically what you can see. Department table is getting joined. Department code. Where it is department code? In faculty table, right? So we can also add faculty table here. But I guess this will not give us any output. Let's see. Yeah. Can anyone tell me why we have an empty output?
Don't have formal columns, I think.
No. Here we have joined with the department code. Here department code. Here department code, right?
Because no students are there in faculties.
Yes, correct. Because no student will be there in the faculty table here, right? You can see. So that's why we got the empty output here, right? So I will remove.
Here sequence matters.
Here sequence will matter.
Because
yes.
in in the tables between which we are putting natural join, so must have common attributes.
Yes, yes. So if we are joining three tables, then it may matter. Okay. So here we are using a faculty. Let's go with a different table here. So let me minimize this one.
One thing, sir, does it create a new table?
No, no. It's just the output. Okay. It is not creating any new table here. It's showing us the
Sir,
output.
I couldn't understand why it is showing empty table. Once could you repeat that part?
No, see here we have three tables: department, student, and faculty. Right. So we join.
Yes. So, if we want to create a new table using this natural join, then what will be the steps?
So if you want to store the output of SQL query in a different table, right?
Yes, sir.
So we can create a view for that. Okay, that's a temporary table we will have. Okay, if you want a permanent table, then you can create a materialized view. So I will discuss in the later part of the session. Okay, what is view? Okay.
Sir, one doubt is coming in my mind, sir. These two tables may not have the same shapes.
Same? Can you repeat?
Same shape. Because the student table will have many rows, and this department table will have less rows. So does the row will repeat? Will the row?
Yes.
Rows will.
Yes. We'll get back to that. Okay. So let me explain this one. I will show you theoretically how natural join works. Okay. Yeah. So see here, this is how natural join works. And let's say, for example, yeah. So what we are discussing. Let's say, for example, we have two common attribute instead of one. Then how natural join will get work? It will try to match based on both the common attribute here, right? But that will not make any sense if you want to get the data here. So that is more applicable to FLIS database. So be careful while using a natural join in FLIS DB. We'll discuss that. Okay. So is this clear about the natural join?
Yes, sir.
Okay. So let me just execute one query on FLIS, so that will be much clear. Otherwise, we'll try to understand theoretically how joining is happening here. So here we have teams table, here we have players table, right? Yeah. So if I join these two table, teams and player, if I perform natural join, tell me what will happen. It will work, it will throw error, or what? Teams and players, we can see we have a team ID here. Yes, anyone? Teams and player.
It will join, sir, I think.
So let's start from.
So it will create a join.
Okay, but what will be the output? Why we got empty output here?
No team with IDs player.
No, there is, you can see we have a primary key here, we have foreign key, right? So team ID is matching definitely here.
But team ID is there for team, and that here it is for player.
Yes, yeah. So we have T001.
Join with a team ID.
No. Why natural join is showing this empty output? That's my question. So you can see teams table here. We have team ID T00001 like that. If I execute players table, here also we have this T001, right? So information of teams in the teams table, information of players in the players table, and you can see this player Rudra belong to T001. You can see then 3, 4 like that. So we have a matching record here. But why we are getting the empty output after joining?
There are no column common attributes.
The common attribute is there. No? You can see this team ID. Just read this definition what I have written here.
Because your primary and foreign keys.
No, primary key, foreign key is there. Yes, that is, but it will.
name are
in
different.
player, it is not the primary key.
No, you can see here name, right? Someone mentioned about name also, right? So you can see what I said, automatically join based on the common attribute. Now what is common attribute here? Team ID is there, but you can see name and name here, right? Name, team's name and player's name is same. So what this is doing, it is trying to match with the team ID also, along with the name also, right? So this is basically equals to where teams dot team ID equals to players dot team ID and teams dot name equals to players dot name. So ID will get matched, but player name cannot get matched, right? So team name and player name cannot be the same. So that's why we are getting an empty output here, right?
So
So
in
in the
team
case of
relation,
FLIS,
the name attribute shows the name of all teams.
yes, you can see select star from teams. So here we have 5 6 teams. That is basically Amigos, Thunder, Rainbow, Black Eagles, All Star. But here we have the players name, right? Rudra, Advik, Veer, Ahmed, like that. So be careful while using a natural join. It will automatically join based on the common attribute. This is what I have mentioned here, right? So in the case of FLIS, if you look at the entire scheme of FLIS, you cannot use natural join anywhere in this database to get a join, okay? To join the tables here. You
So
can see
what
match
is
number.
FLIS?
Sorry, we have three databases, FLIS, LIS, and eShop. If you look at the resources from instructor, right, our
So,
portal.
sir, sir, I have
Huh?
a doubt. So, if we have a more than one column common in both tables, so how can we find?
So in that case, we have to go for different types of join. Okay, natural join will not work in that case. Okay, so we can use natural join only when if we have only one common attribute between the tables. Okay, that's it. Otherwise, always go with the inner join. We'll discuss what is inner join. But before that, I hope natural join is clear now, right?
So only one common attribute should be there to have a natural join.
No, not to have a natural join. I am saying if only one common attribute is there, then you can go for natural join. Otherwise, if you perform natural join, it will try to match with all the common attributes here.
Yes,
You will
sir.
not get the required information here, right? Like
Sir, if there are no common attributes, will it just be a Cartesian product?
yes. So if we don't have a common attribute, so if no common attribute is there, then it will perform Cartesian product. Okay, that is basically a cross join here. Okay, so three things to note here. If natural join will work automatically based on the common attribute. If no common attribute is there, it will perform the Cartesian product. And if we have more than one common attribute, it will try to match with both the common attributes here. Okay, but in that case, we will not get the required information here. It will not show an error because anyway it is performing a joining operation, right? So there is no syntax error in that, but we will not get the required output here. That's what I'm saying. Okay, so this is about a natural join here. Now, what is Cartesian product, or we can say cross join? Yes.
Sir, I have doubt. If we use select star from departments, natural join students, then will the result be same?
Select star from department, natural join students. Yeah, this is what we have done. Natural join in LIS, na? So this department and student belong to a library database. You can see we got the output because here we just have one attribute in common, that is department code. But in the case of FLIS, it is football league system. You can see we have team ID along with the name, right?
No, the sequence of column may differ.
No, sequence of column doesn't matter here, right? So it simply try to match with the common attribute. That's it.
Okay, it may happen that some of the attribute for some of rows there will not be any match of attribute.
Yeah, that will not be there in the output. Okay.
Okay.
Yeah.
So,
So just a second.
that row will omit.
Yeah, that row will not be there in the output.
Okay. Thank you.
Okay, just a second. We'll discuss that part. Same thing applies to a Cartesian product, but before that, let me quickly what happened. Okay. Yeah, is my screen visible? This white screen?
No, sir.
No, sir.
No?
Yes, sir.
Yes, sir.
Now,
Yes, sir.
now, yes, sir.
Okay, fine. So let's say, for example, here we have a student table. I will say S. So here we have a name. Here we have a roll
Sir, blank
number.
white page is visible, sir. Like a Google Chrome page is visible.
No, I am
Nothing
writing on the slide. That is not visible.
No, sir.
No, sir.
Now?
Yes, sir.
Yes, sir.
Yeah. So here, let's say, for example, we have student table. In that we have name, roll number, and let's say here we have a department code here, right? Department code. Okay. So let's say, for example, here we have a department table. Let's say, for example, D. Here I have a department name. Here I have a department code only. That's it. Okay. We just have 2 rows. Here we have 4. So let's say here we have name. So A, B, B, C, C, D, E, F, G, H. Roll number 21, F1, 21, F2, 21, F3, 21, F4, 21, F5. And let's say department code, let's say CS, CS, YUME, YUME. Let's go with MCA. Let's go with here IT. Okay. Department code here we have CS, YUME, MCA, IT, EE. Okay, like that. So I am not writing. I hope computer science, then mechanical, then MCA, Master of Computer Application, Information Technology, Electrical Engineering. Okay, this you can understand. Okay. So now I am performing a natural join. So let's say select star from student natural join department, right? So what we have discussed, it will try to join based on the common attribute, and you can see department code is a common attribute here. So based on that, it will try to join here. Now see what will happen. CS. So CS will try to match with CS. Yes. So in the output, you can see here. So name will be there, roll number will be there, department code will be there, and department name will be there. So all the columns, because we have projected what? Star here. So you can see AB 21 F1, department code is CS, department name will whatever we have that will be there. Then again second row will try to match with again here. Where is CS? Okay, sorry. Yeah, this will work. Okay. So this is one example. We'll take one more example. Don't worry. Okay. So this is CS. Again, it will try to match with this CS. Yes, again, that will be there. Okay. Information. Then YUME will try to match with YUME. So that YUME will be there. 21 F3. MCA will be there in the output. MCA 21 F4. Okay. Now, what about this 21 F5? Can anyone tell me what will happen? Wait. Why I have written? We'll remove this IT here. Let's say, for example, IT is not present inside the table. What will happen now? What about this one?
It will be ignored.
It will be blank.
No, it will be there in the output or what?
No, sir.
No.
No, sir. It will be ignored.
Right? So it will
Basically null type.
No, it will not be in the output. It will simply try to match whatever the matching record here we have in common columns. That's it. Okay. So in the output, just 4 rows will be there. like that.
Sir, but data can't be like that, right? Like, if there is no department, how could a person be a student of that department?
No, yeah, we know that, but I have just discussed this to understand.
Okay. Oh, sorry.
Yeah. Okay, like that. So this will be there in
And
the
sir,
output. Huh?
can you explain that also select star from department, natural join students?
Same thing will work. Department, natural join, like whatever we have discussed, same thing. Other you try to match with CS here and here, so it will get matched with this also and this also. That will be in the output. Again, yummy will try to match with yummy here. That will be there in the output. Okay.
Okay, but in case the IT is there in the department, but that student row with department code IT is not there in the student table. Then
Yeah.
in that case
Also this will not be in the output because we don't have ID department code here, right? So it will try to match with the values only. CS, so this will get projected. ME, so this will get projected. MCA, so this will get projected. EE, we don't have EE, that's it. So output will be 4 rows only. Okay. So we have few questions in objective assignment. That will be easier to if you go through PA and GA objective assignment. So that will help you to understand the concept of this natural join. Okay, how it is working, theoretical concept. Okay.
Sir, suppose department codes are common, but the other values are null. So will it be projected in the table?
Yeah. So if you are saying if this is null, right?
Yes, sir.
Yeah. If it get matched with MCA, so that will be there in the output, and here that will be a null here.
Okay.
But here you can see roll number cannot be null if we put the concept of primary key, right?
Yes, sir.
Yeah.
Sir, in the PG admin, you wrote about cross join, sir. Is cross join and when we write from, let's say, one table comma another table, is cross join that in Cartesian product? All three of them, are they equivalent or are there any differences?
All three are same basically. So cross join, right? So either you put S comma D. So whatever we have, select star from S cross D, select star from S, then put cross join D. So both will give the same output. So both will perform a Cartesian product only.
Got it, sir. Got it.
Okay. So how Cartesian product will get performed? You can see there is no concept of matching values or columns here. Simply this row will get matched with all the, let's say we have some row here as well. So this will get matched with all the rows here. So here we have 5 rows. Here we have also 5 rows. So in the Cartesian product, 5 into 5, 25 rows will be there. So every row will try to get combined with all other row from the table. Here also same, this second row with all the 5 rows. Again, this with all the 5 rows. So in this way, we are going to get 25 rows. Okay, we will see how it works. But I hope the concept of natural join is clear now, right?
Yes.
So let's quickly go to PG admin. This. Yeah, so here you can see Cartesian product. Now let's try to perform Cartesian product with student and department. So select star from students, select star from departments. So if I see student table, we have how many rows? 52 rows, right? If I execute department table, how many rows we have? 4 rows, right? Now let's perform a cross join here. Select star from students. So either you can specify the cross join keyword itself or simply comma, both will work. Department, so that's it. So you can see we got 208 rows, so 52 into 4, right? So this will also work and this will also work, simply comma. Okay, you can see. So either you can go with any of this. So you can see most of the people just simply do table 1 comma table 2, then they put their where condition like that, right? So that is also fine. But if we have more tables, so sorry, more table, not more number of record, then always go with the inner join. We'll discuss that why. Okay. So let's say, for example, we just have 52 rows and 4 rows, right? And what we want here, we want to join this table. So you can see we got this output 208 rows, but there is no meaning to that, right? This row doesn't make any sense here. Ajay, Mahato,
Yes, sir.
then we have this one, ME code, block 3. Let's see with this one. So here department code is electrical name, and this belong to mechanical, right? So this row is redundant, doesn't make any sense here. Like that you can see, right? So
It
we need
is,
to do,
it is Cartesian product.
yeah, it's simply a Cartesian product. That's it, right? So it's not of any use, this data. So we need to filter the output. So again, we are putting a where clause here, where we need to specify that students, so department code from the student table, department code from student table must be equals to department code from department's table. So you have to specify the table name, then full stop, and the attribute name like that. So now this will get matched here. Okay. So now we are going to get the same output as the natural join. You can see 52 rows. But the thing is, in the case of natural join, you can see we just have one department code. But in the case of cross product, you can see, or Cartesian cross join, you can see we have 2 department codes. So basically same values we have, but 2 columns will be there if we specify like this. So if you are performing a cross join, make sure you join the table based on some condition here. Join is filtering the output here. But in the case of natural join, automatically this is happening here. We don't need to specify this condition in the case of natural join. Okay. I hope this is clear.
Sir, could you repeat the last statement once again?
Yeah. So in the case of natural join, we don't need to specify this condition, right? Simply select star from student natural join department. So automatically it will join based on the common attribute. But here in the case of a cross join, we need to specify the where clause, and then we are filtering based on this condition. We need to mention the joining condition here, you can see. Right?
Yes, sir. To make the connection between
both the tables,
rightful attributes.
Yes.
So, but in this we'll have duplicate common attributes, right?
Yeah. In this case, we have a department code twice. So if you just try, let's say for example, roll underscore number, then we have department code, right? Now database and will get confused which department code, because we have 2 department code here. So it will throw an error. Let's see. You can see department code is ambiguous. So we don't know which department code. So we need to specify any table. Let's say for example, student table like that. So now we are projecting a department code from a student table, right? Like that. So in the case of natural join, this error will not come because automatically it will remove the one common entry. That's it, right?
So here we need not to write a cross join.
Yeah. So either we can just put like this or simply use cross join. Both are the same thing. Okay. Yeah. But here if we put like this, so if we have this joining condition and if we have filtering condition, let's say for example, date of birth after 1st January 2003. So I want date of birth greater than 2003, then 0101 like that. So you can see here, we'll get the filtering thing here like that. Okay. So you can see we have to mention this table name multiple times. Here also, if you want department code, I need to specify like that. So the best way is that you can use alias. So student, you can use as, then S, then also here department as D. So you don't need to use students and department. You can simply use now S here and here department D here. That's it. Okay. So now here also you don't need to use the student dot department code. You can also put student S dot department code here. Okay, like that. So either you can go with this one So this is the best practice because we don't need to write a table name multiple times, or it depends on you. So it's not necessary you have to use this also. You can simply give space and D. Here also simply space and S. So both the things will work. Okay, you can see here. Anyone any doubt in whatever we have discussed in cross join?
No, sir.
Okay, great. So this is about the cross join. Now let's discuss about the inner join. Does anyone tell me the syntax for inner join? Again, we have a students table, then we have a department table. I need to join this. What should I have to write in between? Yes, anyone?
Inner join.
Inner join. That's it, or what?
On, I think on.
On clause we have to use, right? So student S and department D. On which attribute I want to perform the joining operation, that is what we need to specify. So same thing like what we have done here. Here you can see we can write it down. So
Sir,
this also join.
if we don't specify on, what will happen? Will it just behave like natural join?
No, it will throw an error. This is part of syntax. It's a syntax error. So whenever you are using inner join or outer join, you have to use on clause. Otherwise, it will throw an error. It's a part of syntax. Okay.
Sir, here, if assuming we do not use the alias, can we just write department code on department code?
No. It will not match. We need to specify the table name.
We have to specify the table name and equate it.
Yeah.
So that is compulsory. Okay.
So department code from student table will equals to department code from a department table. This is what we are mentioning here, right? So that's the only difference between inner outer join. Sorry, inner join and cross join. Here we have to use inner join. On clause will be there, and we have to specify the condition. But you can see here department code is here as well, right? So here, in this case also department code will get repeated. Okay, like that. So this is about the inner join. So inner join, then natural join, you can see the same output here. In the case of natural join, only the common column will not get repeat, but the number of rows will be same. Okay, data will be same. Okay, so this is
So
about
even if we don't write inner, it will be like inner join only, right?
yes. Even if we skip this inner, it will perform inner join. Okay, like that. So see here, natural join we know it will automatically join based on the common attribute. So if we have more common attribute, we cannot perform natural join, because otherwise like it will try to match with all the common attributes. So in that case, we can go with the inner join here. So you can see in the FLIS, we are not able to join this teams and players table. Means we got the empty output here. Now if I perform the joining here, so teams, and then here we have players. So I can perform the inner join here.
Sir, so it will show a single attribute, sir, if for common attributes like natural join.
Yeah, only one time it will be there. Department code. It will not get repeated.
Okay, sir.
So here you can see we are joining based on the team ID, because team ID is the, you can see this foreign key and primary key concept here, right? So it will try to join based on this one. So this is the correct way to join the tables in FLIS. So if you come across any question in assignment or in OPE, so make sure you go for the inner join in the case of FLIS DB. Natural join will not work in the FLIS. Okay, if you see entire schema, it's designed like that only. Okay.
Sir, you just wrote join, sir. What about inner?
Inner join and join both are same thing here. Okay.
Okay, sir.
Okay, so this is about inner join, right?
Sir, sir, can you just re-clarify on why this will not work on the FLS?
Yeah, you can see in the Football League database, every table you can see we have something common. So here, like two common things are there. Team ID, common name is there. So natural join will try to match with both the common attribute here. So we will get the empty output, right? So we will not get required output here. Even if you Yes.
Yeah. So if you, for example, so what I understand is when you have common fields, common attributes, it'll eliminate all the common attributes, and the remaining one should occur. No, at least some of the tables have more than common attributes.
Yeah. So it will try to match based on those common attribute also. So team ID will try to equate with team ID. Also, name will try to equate with name here.
Oh, so it will not match. Both will not match. So
Anyway,
that's why you
team's name
don't
and
get.
player's
Okay,
name
okay.
will not be same, right?
Fine. Okay, right. Thank you.
But you can see here match referee and referee. We have a two table, and here you can see this is a primary key. Here we have a foreign key. So here also we cannot perform natural join because you can see referee underscore ID is there. We don't have that attribute name in the match underscore referee, right? So if I want information about the assistant referee one, so I have to join based on this thing. Okay, so let's try to join here. Select star from referees in the join match underscore referees. So this is Yamar, this is, let's say, R on Yamar dot what. So you can see match referees. So I want assistant referee information. So I will use this attribute name now. Yamar dot assistant underscore referee one equals to referee ID is there, right? Referee ID here. You can see referee ID. So R dot referee underscore ID. So you can see I'm getting information about the assistant referee one here, right? We have joined based on the assistant referee one here. You can see this is the record for assistant referee, name of the assistant referee one. Okay. If I want a detail of referee two, simply we'll go with the assistant referee two. You can see here, right? So this is the thing like that. Okay. So you can say execute this one. So if I want to join these two tables, I cannot go with the natural join because there is no common attribute. So what will happen if I perform natural join here in this two table?
Cartesian product, sir.
Yeah. So this will give us Cartesian product. That doesn't make any sense. That's why we cannot go natural join. We cannot. We can go for a cross join, but best way to go with the inner join. So I hope you
Sir,
understand. Yes.
once could you repeat that inner join? Why did you do in this referee thing, sir? Like why it is better than natural join? Once that part once again, could you say?
Natural join we cannot perform here because there is no common attribute, right?
Yes, sir.
Yeah. So that's why we have gone with the inner join. We cannot perform natural join.
But for inner join also we need some common attributes, right, sir?
No. We have to specify how joining will happen here. So on assistant referee 2 from matches referee is equals to referee ID here. You can see we are joining based on this condition here. So here we can put any condition. This roll number equals to name, but doesn't make any sense, right? But here you can see here all this referee ID is present in the referees table, right? You can see this one, all are the foreign keys, right? Like that. So here I can match with any one of that. It's not like that the referee ID must be present here as well. So we can joining based on some condition. Some on clause is there based on some condition here we are performing, right? So
okay, sir.
If I want a data of a referee only, so I will join the referee with this one. That's it. Okay, like that. So I hope you understand the limitation of natural join here. And cross join also we can perform here. Simply what we need to do, instead of inner join, we'll specify this as comma or cross join, and here instead of on we have to put where. Okay. So this will work, right? Both the things will are same output only, but the difference will lie when you try to execute at a bigger database. Let's say, for example, you can see here we have student and department. Let's say I have this much number of student and I have this 40 department. Then if you perform the cross join, what will happen? This much into this one, right? And then you are filtering the output. So it will take long time to execute the query. But if you perform a inner join, so before getting an output, it will try to match with this one. So this is you can see a lot quicker than this one. So time it will take less inner join. So that's why we say always go with the inner join. Okay.
So that means cross join is only theoretical concept. Actually, in practicality, we can use inner join.
Yeah, Cartesian product. So this joining happens from cross join only. How
Yeah.
the database is performing, but you can see here inner join will take less time.
Yes, sir. So what my question is, for all practical purposes, we should use cross join. Sorry, I mean,
Inner join. Yeah.
inner join only, not the cross join.
So best way is go with the inner join only, because in
Okay.
some database, some table, natural join may not work, right? In some case, cross join will throw some error. So best way to go with the inner join, because if you look at the resources that what we have provided, in that we have university database, right? So if you see, I don't know whether we have that or we have removed. Let me check. Resources from instructor was the SQL resources unit. Just a second, let me check.
So in most cases, inner join will work.
Yeah, inner join will work. We just need to put the condition. That's
Condition. Okay, thank you.
Yeah, you can see in the data set folder we have university database, right? So you can try to execute the cross join on that because it has lot more many rows, right? So it will take more time to get executed. So that's why we have removed all the questions from university database, because during OP it is taking time to execute the query for university. So in OP you will not get any question from university database, only FLS, LIS, and TSHOP. Okay, so you can do that.
Sorry, doubt.
Yes.
Can we join more than 2 tables in
Yes, yes.
using inner join?
Yes, yes, we can do that. So here I have perform student and department. Let's go with any other we have. Let's go department table is joining with what? Which table is this? Members table, right? So I can join the department student with the members table because roll number is a common attribute, right? So here I will put join members. But be careful, you should know which attribute is common here. So I know roll number is common here. So I am joining on m dot roll underscore number equals to s dot roll underscore number, right? Because roll number is a common attribute here, right? If I try to execute,
Yes, sir.
see, this is the output we are getting. Okay.
Okay.
Sir, can you explain it once again?
So if you want to join 3 tables, here we have student, then department, and then we have members. So first we are performing a join between 2 tables. You can see student and department table based on this condition. Then we put one more join here. Sorry?
It is inner join only. No?
Yeah, inner join. Yeah. Then we put one more joining condition, then a third table, and then the condition. So m dot roll number, because roll number is common between members and a student table. You can see this roll number. So we want to join based on the roll number here. So we have specified the condition.
Sir, could you once put brackets in this and tell us what is going first, and then?
Sorry, bracket means what? Can you repeat?
To make it just a little bit more clear, sir.
So here we are performing a joining between 3 tables: student, department, and members.
Right.
So what first we are doing, we are joining based on the department code. So student and department is getting joined, and then join with the members table. But how it will get joined? So on m dot roll number. So roll number from members table is equals to the roll number from students table. Sorry.
Sir, you are not audible, sir. Your voice.
I'm not audible.
Now you're audible, sir. No.
Okay. Yeah. So I'm audible, right?
Yes, sir.
Yes, sir.
Yeah, clear, sir.
So you can see here we are performing a joining between 3 tables here. So first we are joining 2 tables based on the condition, then join with the third table based on some condition. This is how we can perform multiple joining. If you want 4th table also, we can do that. So members will go to what? So member is basically a quota here. You can see a member ID will go to what? Member ID should go to faculty or book catalog. I don't know it. A minute. So member number is where it is going. It is table. Book issue. Book issue. Okay, great. So here we have a member number. Here we have book issue. Now I want to join book issue also here, right? So what I will do, then again put one more join that table. But I can join this book issue with which table? Here you can see book issue I can join with only members table. That is a member number is common here. I will specify this one. This is basically BI. So BI dot member. So member underscore number equals to what? M member underscore number.
Sir, this select star is applying to all of the text starting from and to the end. Is that correct?
Yes, all the attributes we are going to get from all the tables here. You can see.
So all the joins are part of that from keyword.
Yes. Yeah. From here, first joining is happening, then we are projecting. So I will discuss also the precedence of how this all.
Sir, why department code is repeating twice, sir? Like it's in natural join.
No, it's a inner join we are performing, right? So inner join, cross join, the common column will get repeated here. You can see. Okay. Only in the case of natural
And the row, repeated row will be included here.
So which row is getting repeated?
I think I am asking.
No, rows is the row will not get repeated because you can see we are joining based on some condition, right? So automatically you can see here there is no redundant row because we are joining based on the key only, right? So if you see here, if I just execute this one without the book issue, how many rows we got? 52, right? You can see at the bottom, right? Now if I execute entire query, how many rows we got here? 20 rows. Now can anyone tell me why like that, or what we can infer from this? If you understand the database of library system, right? We have department, we have student, we have member of that department, we have book issue table. If 20 rows are there in the output,
there are few data which are not matching, so that's why I guess they are removed, sir.
so what we can infer from that? I am asking about the information we can get from here.
Okay, so students who is having book issue.
Yeah, so there are 20 students who have issued the book, right?
Yes.
So there are 20 students out of 52 who have issued the book. Like that, we can say. So if I ask for, tell me number of students issued the book. So simply you can go with the count star here. The number of students issued the book is basically count star. Is aggregate function get covered in the previous session?
Yes, sir.
Okay. So you can see count star here. So 20 students will be there.
Sir, so the last join would be having such a priority of value. Like what I want to say is 20. It's decreasing from 52 to 20 because of book issue, right?
Yes. Because here you can see. So if I execute this one, what is telling us? So we have 52 students who are the members of library, right? Can we say like this?
Yes, sir.
Yeah. And out of this 52, if I join with the book issue, 20 students have issued the book. You can see. Okay. Here we have 52 students who are the members of library. You can see. Okay. So
Sir,
yes.
So instead of this join, if we use natural inner join, then the repeated attributes will be cancelled, right?
Yeah, repeated attributes will not be there. But if you see natural join can be performed, department student will get matched. Then department member will get matched. Member book issue will also get matched. Yeah. So here also you can perform
I am saying
natural join.
Natural inner join.
Natural inner join. No, that will not work. Either natural join or inner join. Okay.
Sir, my doubt was not clear. Like I couldn't understand why department is showing once again. Could you just repeat that twice?
Department code, right? Yeah. So we are using inner join. In the case of inner join, common columns will get repeated.
Like in Cartesian product, can we say?
Yeah, in Cartesian product also we got the department code twice, right? Here also.
Yes.
Only in the case of natural join, common column will be repeated only once. Only once will be there. That's it.
Okay, so inner join is not a substitute for natural join for more than one common. Can we say that? Because it's repeating, right? Twice.
So here we are doing select star, that's why. But in general, we want few columns only, right? Not entire record. So we just want first name, then mobile number, then we want a few roll number, member number, like that. So here we are doing a select star, that's why we are getting that one. Okay? That's it. So in the
Yes.
case of inner join and cross join, this common column will be repeated here, because here we have performed department code, but if you see here, this one, right? Assistant referee 1 equals to referee ID. This is a different table, a different spelling, different attribute, right? So that will be there. Okay. Only in the case of natural join, that common attribute will be only once. That's it. Okay. I hope this inner join is clear to everyone now. Okay?
Sir, a last question. So inner join is just for time complete, like to get the things done faster, we use inner join rather than cross join. Am I right,
Yes.
sir?
Yes. Yeah.
Okay, sir.
Because if I want to perform a cross join here, right? So let's see. Let's execute this one. You can see query complete this 292 at the last, right? Whatever
Yes, sir.
Let's try to execute with the cross join here. So here I don't need to specify the join, simply department. Then here I again comma with members. So I can simply put comma and number of tables I want to join. So members M. After that, what is book issue we have? That is BI here, right? And then we are putting the where clause, and all the conditions you can see that will be and here. So this also get removed. This is removed. So this will get removed, and this will be. So see, let's start from student, department, comma members, comma book issue. So we have performed what we have done here. Cartesian product of 4 tables. Okay. Then we are filtering the record based on this condition. So department code must be same, the roll number must be same, and the member number must be same, right? So if you see this one, output is 20 rows, right? So here also we'll get the 20 rows here as well, right? So yeah, you can see here, this is how we can perform, right? But if you see, if we have more number of records, this will take time to get executed. Okay.
Yes, sir. Got it, sir.
So best way is to go with the inner join. Okay. So don't get confused. Whenever you want data from multiple table, always go with the inner join, safer side, right? Natural join will not work if we have more common attributes. Cross join also, cross join will work, but it will take some time. So better to go with the inner join always. Okay, so this is what we have discussed. Then about outer join. So we have right, full, and left. So yes, anyone, what is left outer join, full outer join, right outer join? Anyone?
It will give all the attributes of left table.
Yes. Not all the attributes. Let's see. So we don't have, I guess,
On the
any
primary key.
So
yeah, yes.
Left outer join will give us values. It will not ignore the values. It will perform the filtering based on left outer join and compared with right table, and the left table values will not be ignored.
basically, sir, it will join on the basis of column, common column, and remove the right table columns.
Yeah, we can say. So it will give
So
us.
it will take the all the columns between 2 tables and all the tuples from left table.
Yeah, you can say remaining rows from the left table. So this is basically equivalent to what? The output of inner join, and remaining rows from the left table. So first, it will try to match based on the condition. Okay, so whatever the condition we have, it will try to match based on that. So member number, book issue we have joined, right? So let's go with this one. Member or book issue. Members, book issue. Okay. Just a second. So here we have 68 rows. Right. Let's see how many rows we have here. 21 rows. Okay. Here we have 21 rows. Sorry. So if I perform an inner join here, so it will try to join based on this condition, member number, right? So we are going to get what? 21 here, because 21 members of library have issued the book here. This is what we can say here, right? Now, if I perform the outer join here, right? So outer join, first let's discuss about the left outer join, right? Now see what will happen. Okay, so you can see the output of this inner join here, right? We have, but if I perform the left outer join, so we got 69 rows here, right? So you can see first we are getting a output based on the common attribute what we have performed. It will try to match with the member number of book issue with the member number of a members table. So that is basically 21. But then left outer join will also give the remaining rows from the members table, left table. Members table is left table, so you can see here. So you can see some null values are there, right? Can you see this? Yeah. You can see these are the members. These are the members, faculty you can see are the members of library, but they have not issued any book. So first it will give us the values based on this condition, then remaining rows from the left table. That is what the left outer join is. It will give us the common values based on the condition, based on common, or we can say matching values. Okay. So matching values based on condition, and then remaining rows from the left table. That is basically inner join plus remaining rows from the left table, we can say here. Okay.
Sir, when you say remaining rows of the left table, will the remaining rows of the left table will it be joined with each and every tuple in the right table, or will it just be given as the left table and then null values for the right table?
You can see all these are the remaining rows. So it's that as it is, and but value for the corresponding this three attribute will be null. You can see.
Okay, sir. So so the ones which are not matched in the left table, they will just be written once, and everything on the right table will just be written as null when you join them.
Yes. If we don't have a matching entry for that record.
Got it, sir.
Yeah. So just a second. So this is about left outer join. Similarly, right outer join will work. Only the difference is right table, remaining rows from the right table here. Right. So just a second. Is this visible?
Yes.
So let's go with this only. So CS, ME, MCA, IT. Here also CS, ME, MCA will remove IT. Instead of IT, we'll add one more here. Let's say, for example, data science. Data science. Okay. So here we have 5. Here also we have 5. Right. Okay. So first we'll perform the left outer join. Okay. So see how it will work. So select tab from student, left outer join, department. Right. So we are joining based on what? Department code here. So S dot department code equals to D dot department code. Right. Now see, first CS will try to match with this CS. So that row will be there. I'm just writing 21 F1. Then this row will again try to match CS, again 21 F2. Then again ME will try to match with the ME, that is 21 F3, 21 F4, right? Now 21 F4 will try, so here MCA will try to match with MCA, that is 21 F4 as well. Then 21 F5 we have IT. Do we have IT here? No. So if we perform an inner join, this is the output we got. Or natural join, this is the output we got, 4 rows. But in the case of left outer join, you can see 21 F5 will also be there in the output because remaining rows from the left table we are taking. And you can see here department name, whatever department name, we have computer science, ME, this MCA, then we have this two computer science, right? Then ME, then M computer application. But for this, we don't have any department code here, so that will be null. Okay. So we will get name, roll number, department, all the things, but in the output we have more than these two attribute also, department name and department code. So that will be null. This is what I am saying, right? So first it will try to perform join based on the condition, then remaining rows from the left table. That is what left outer join is. If I perform a right outer join, so now it will take remaining rows from the right table, that is department table. So same thing, this will get matched here. This 4 rows will be there, but so this 4 rows will get matched, 2 of CS, 1 of ME and 1 of MCA. But what about this data science? So data science and electrical engineering will also be there, and the values corresponding to name, roll number, department code will be null. This is right outer join. I hope the difference is clear now.
Yes.
Right. So in this case, we got 6 number of rows. In the case of left outer join, we got 5 number of rows. Okay. So there are a few questions in the quizzes or end term. If we perform left or right outer join, how many rows we are going to get, maximum, minimum. So that's the concept we have to apply here. Okay. It's about the left outer join and right outer join. Then we have something called full outer join. Now tell me how full outer join will work.
All the rows.
Both left and right.
Yes.
What are not matched will come
So
as
first,
null.
based on the common attribute, so 4 rows we got. Then remaining rows from left and right table. So this is our left table. Right table will be 21 F5, and this will be null here. Right. So in the full outer join, there will be 7 rows in the output. Okay. So all the information for this 21 F1 department code will be null here, and for EE, so that name and that will be null here. Okay, like that. So you can try to execute in the pgadmin because we don't have a proper example to discuss this left or right outer join. The member and book issue was the only thing. You can just simply interchange the member and book issue, so you can perform the right outer join as well. Okay, so I hope the outer join is clear now. Anyone, any doubt in the different types of join what we have discussed?
So in the full join, we just include both the outputs of the left outer join and right outer join, like
Yes.
last two rows.
Yeah. So first matching output based on the condition, then the remaining rows from the left and right table, and the corresponding value for left or right table will be null if we don't have a matching output. Okay. Okay. So this is what about the outer join is. But for SQL query, always go with the inner join. It's up to you. You can go with the cross join. There is no issue, but we'll recommend that go with the inner join during OPE exam. Okay. Okay, so outer join, it depends on the problem statement. Okay, so you can go with any of the joins. So left or right will work in the same way, just the left table and right table concept is good. Okay, great. So now we'll discuss about group by clause. Is this discussed group by in the previous session? Hello?
It was part of week 2, I think, sir. And some of the questions came up in group by.
Okay. Yeah, I hope it was discussed in the previous session, or I will quickly discuss this part.
Sir, by the way, when is this OP exam date, sir? Is it
after quiz 2?
After quiz 2, okay.
Yeah.
Thank you.
December 7th, I guess, sir.
Yeah,
Okay.
after quiz 2.
Right.
Because week 7 content will be there in the OP.
Okay.
Sir, there is only one OPP or are there two?
No, only one OP exam.
Okay, sir.
If you
And
fail OP1, then you will get a chance to attempt re-OP next week, I guess on 14th or 15th December. Only if
sir.
you attempt and fail the exam. Otherwise, no. If you absent, then you will not get the chance to re-attempt. Only if
Got
you
it.
fail. Yeah.
Sir, and in the OPP exam, apart from the Python DB question,
Huh?
SQL only from week 2 and 3 will come, or is there more?
No. Only week 2, week 3 is SQL, and then week 7 we have Python DB. Only 3
That's
weeks.
it. So only 3 weeks OPP is based on.
Yes.
Got it.
2, 3, and 7, sir.
2, 3, and 7.
Okay, thank you.
So we'll have special session, dedicated session for OP just 1 week before that. So we'll discuss about OP in those sessions. Okay. So aggregate group by. So we know what are the aggregate function. Yes, anyone?
Min, max, average.
Count, sum.
Average, mean. Then we have max. Then we have count.
Count.
The one. I hope the working of this one. That's for which purpose we use. Some will use summation of that all the columns average. You find out average. Mean will use minimum. Max will use max. Count will simply use number of rows. That's it. Right. Now what is group by clause here? Right. So we are grouping by something here. Right. So let's go with some table. Here we have department and student table again. So let's say, for example, I want to find out how many students are there in each department. So whenever you see this keyword, each department, right, each team, so always think about group by clause, because we want to group by team name or department name here. So if I execute select star from students, natural join, departments, here we can perform natural join because only one common item is there. Right, so you can see we'll get all the information here, 52 rows. But I want that CS department, we have this much number of students. From Yummy code, we have this much number of students, like that in the output. So for that, we have to go with the group by clause here, right? So here, if I want number of students in each department, so first I want number of students, so that will give me from count. So count star, or you can use roll number also, primary key, anything will work. And then we want department code as well. Department code here. Okay. And now, okay, what will happen if I execute this one? Can anyone tell me?
It gives error, I think.
Will it show an error?
It will throw an error because you can see, right? So department code must apply the group by clause or to be used in aggregate function. What does this mean? So if you are using any aggregate function inside the select clause, average, minimum, maximum, aggregate means what? Simple single window, we can say one row which we are going to get. Sum is also one row, average also one row, minimum, maximum also one row, count is also one row, right? In department code, we have 5, 6 department code. How we are going to get the output, right? So count star. So whatever or aggregate function you are going to use inside the select clause. So if you are using aggregate function, you have to use. Sorry, wait. If you are using any other attribute along with the aggregate function inside the select clause, so that attribute must be a part of group by clause. So you can see group by department code here. So if you are using a attribute along with the aggregate function inside the select clause, so that attribute must appear in the group by clause. Otherwise, it will throw an error. So you can see. So this department we have 12 students. MCA department we have 10 students, like that. Okay.
Sir, if department code is not there in select, so we did not use group by?
Yeah, so it will work. So count star will give me a number of rows. You can see 52. That's it.
Okay, sir.
Or even if you group by here, it will also work. It will give just the number, but doesn't make any sense. What is 14? We don't know, right?
Yes, sir.
Yeah. So we need to use a attribute here, and that attribute must be a part of group by clause here. Okay. So if you are using any attribute along with the any aggregate function, so that attribute must be inside the group by.
We can also use as you want the column output.
Yeah. So you can use number of student here. Okay, will this work if I just put a space and if I put like this number of students? Will this work?
Special character should not be there.
So let's go with
Let's
this
go
one.
with
You can see number of students here. But what if in the output I want this number, then I want this space, then I want this off like that in the heading? Will this work?
No, so we have to use underscore.
No, I don't want underscore. I just want space here. Number, then space, then off, then space, then student.
Sir, you name it as a string, sir.
Yeah.
How?
A single quote. In a single quote, can we use that?
Single quote will work? No. Okay, one more thing. Here you can see number of students like that we got. But here also I want N capital, then I want O capital. Here I want S capital. Now let's see what's in the output. Still we are getting in the lower case, right? I want the uppercase number O and S here. Or I want a space in between. How I'm going to get that? So this is the only thing where we use double quotation in SQL. Okay. We use double quotation inside the select clause here like that. You can see in the output if you want this one, right? Or if you want a capital uppercase also, in that case you have to go with the double quotation. Otherwise, it will be one particular string only, and it will be in the lower case as it is. Okay. But what if I want the header name like that? So you have to go with the double quotation. This is the only thing, only place where we use a double quotation in SQL. Okay.
Well, comma is mandatory here because most of the commands we never used comma. The first time I'm seeing this.
Comma?
Yeah.
Here? No. Here we have two attributes, na.
Oh,
So
okay.
this is one attribute entire.
Correct.
So we need to use
Yeah,
comma. Get that, right? So you can rename the output here, right? So if we have a big database, if we want some data, and if you want to share, you can see a download option here, right? So it will get downloaded in the CSV format. You can see.
So,
you can do that. Huh?
so when we wrote number of students and we had space in between, that off was of different color. Why was it?
I guess it's a keyword, special keyword. But for which purpose we use that in SQL, I don't know.
Okay.
So here we can do some dot graph also. You can see department code and number of students. What happened? Yeah, you can see there is a graph, right? So we can plot a graph also between the output. Okay. So this is how group by function will work. But what if I just want the information of a department code in which we have more than 12 number of students. So I don't want this electronics and MCA. I just want this CS and ME in the output. So total number of students in the department must be greater than 12. So how we can get that output?
Select from where. We can use where.
Okay.
Greater than.
Where?
Select after from, sir. Before group by.
No, before group by. Okay, before group by where then?
No, sir. Having should be there, right, sir, for aggregate functions?
Yes. So see the difference between where clause and having clause here, right? So if I want to filter the output after group by clause, because this is what we got after applying a group by clause, right? So in that case, we have to use having, not where, and that is after group by clause. So having that number of student here, what
count should be greater than.
Yeah, count or number of student you can mention, or count star greater than 12 here, right? So this will try to match. So this is the output. So we use having clause if we want to put some condition on aggregate function, average greater than this, sum greater than this, or count greater than this. We can only use having function. If we try to use where clause will not work. Aggregate function, we cannot use aggregate function inside the where clause. Okay, only having function, having clause will work after group by. So where we apply here, right? So let's say, for example, instead of all the students, we are dealing with male student only. Gender equals to young, we are putting here. Now we will get number of male student greater. Let's see how many male student we have in each department. So 7, 10, 6, 11, and let's go with this number as 7. So then we'll get the output. So these are the department in which we have number of male student more than 7. Okay. So this is how having will work. So having we use whenever we want to apply a condition on aggregate function here. Count, average, greater than this one, sum greater than this one, like that. Okay. Anyone, any doubt in group by having clause aggregate function?
Sir, if group by wasn't there and we had to put a condition on an aggregate function, we have to still use having.
Yeah, we can use having. Let's check that. I guess. Let's see. Yeah, we can do that.
Got
But anyway, it will department code. Right. So here, yeah, we can do that. We need to change the query, but having will work without group by. Okay. Yeah. Okay. So up till now we have discussed select, then we have discussed from. Okay, order by is covered in the previous session.
Yes, sir. I think.
Yeah. So order by simply what we'll see.
Ascending and descending.
Yeah, ascending and descending. So do we have any date of birth we can go with? The which table is there?
We can do the previous one only, sir. Count order by. We can do that.
We can do that, but take easier example. Select star from students. So here we have date of birth. So I want to order this date of birth in ascending order. So order by, then you can put date of birth. Okay, DOB. So if you don't specify anything, so by default it will order in ascending order. You can see here one like that. But if you want descending order, you can simply put in descending order DESC. So you can see the output in descending order we got. Okay, that's simply a use of order by a clause here, right? That's it.
You can also do order by student, F name or L name.
Sorry, can you repeat? Order by?
Order by student first name and student last name.
Yeah, we can do that. But first it will order based on the student first name, like whatever you are specifying here first. So
Yes.
first it will order based on the student first name, and then it will order based on the student last name.
Yes.
Right? So there might be possibility that two students may have a same first name, right?
Yes.
So then based on the last name, it will get decided which will be in the ascending or descending. Okay.
Okay.
So yeah, what we are doing here. This is what department code from student, then gender, then group by department here. Okay, wait, let me add it down. Group by having. Let's remove having and so on. Let's see. Yeah, so now if I want this in the ascending or descending order, I am putting order by as well. Order by number of students. Then the order by count star a number of students. What we need to put here?
Anyone?
Anyone will work. Let's see. Count star. Yeah, if I put the number of this will also work. No, this will not.
Double quotes, sir.
Yes.
This work. Yeah, okay, like that. So see what we have used. We have used select. We have used from. Then we have used where. We have used what group by. We have used having clause. We have used order by clause. Right. So this is order. We have one more thing. Do you know limit for which purpose we use limit offset?
Yes, sir. Limit like first two or first three or top 10 or
Yeah, like that we can do, right? So then we have some limit also here. There it is. Limit also, all right? So if we are using this much number of commands in our SQL query, which will execute first? What is order of execution? That is very important. Order of execution here.
Where first, sir?
Yeah. So first, where clause. Where clause? No.
Sorry, I was speaking before group by, sir.
No, we are using this one. So in which order the database engine will execute this particular command? So you might have seen in many videos, like people, what they do, they, instead of writing a table name, they write a select query, then they go with the output of that select query, then they will try to join with the output of another select query, like that, right? So what I'm trying to say, if we have this one, so how we are going to get the record here? Let's say, for example, I have a student table. If I want the data from a student table, what I will do?
select them from.
So from all this thing, from clause will execute, right? First, I need to go to the table, right? After this, which one? Tell me. First, from
Where?
clause will execute. Yeah, where? So if I want to filter the output, I will filter the output based on the where. So I have gone to a condition, table, then I have filtered the based on the condition. Then after where, which clause will execute?
Group by.
Group by.
Sir, this is different from the sequence we write the code in, no?
Yes. This is order of execution, how database engine execute the SQL query at the backend, right?
Got it, sir.
So first from clause will execute because we need to go to that particular table, or if it is a join. So first we'll join, then only we can filter the output, right? So first we are joining or going to the table, then we are filtering, then group by. After group by,
Having.
After having,
Order by.
Limit or order.
no, select.
Okay.
So you have gone to a table, you have applied the condition, you have filtered the data, you have applied the group by clause, you applied the having. Order by will work based on some attribute, right? You can see here order by number of student. Now we are able to execute this one. Why? Because database knows that number of students means what? Count star only, right? It means what? Select was got executed first, right? Are you getting my point?
Yes.
So this will get order by clause and then it will execute the limit. This is the order of execution, very important concept. You can expect this concept in your interviews or as well. Okay.
Sir, could you discuss about limit, sir?
Yeah. Okay. But this is clear, right? Order of
Yes, sir.
execution.
Yes, sir. Yes, sir.
Okay. So there are two things: limit as well as offset. Okay. Offset as well. So after limit, offset will execute. Okay. So let's say, for example, we have date of birth. Okay. So here date of birth is by ascending order, right? So you can see date of birth in ascending order. We have this much. But what if I just want first five first five rows only? So ascending means what? Youngest one or oldest one? Oldest one, right? Oldest student. Date of birth is 2002, right? If I put descending, then date of birth will be 2000 something. So it is youngest, right? So if I just want the oldest student.
So what is offset?
Sorry?
Sir, what is offset?
Yeah, we'll discuss that also.
Offset.
Yeah, I will come to that. So order by date of birth, you can see in ascending order. But what if I just want first five record only? First five youngest student, not youngest, oldest student we can say, right? Because date of birth is what? Highest here. So here I can put the limit 5. So this will give me first 5 rows after applying order by clause. So first 5 rows only you can see here, right? That's it. Limit means simply number of rows after applying the group by clause. That is what limit is. Okay, I hope limit is clear. If you just want 2 rows, so it will give us the 2 rows. Or if you want to find out the name of or information about the oldest student, that is basically limit equals to 1 here, because his date of birth will be the lowest, right? That is what limit is. But let's say, for example, I want 5 rows, but I don't want a rows from the top 5. I want to skip the first one. I want to skip this row, and then I want next 5 rows. That is basically offset, as name suggests, offset. Offset 1. It will skip first row from the top, right? So that is what we are going to get. You can see Robert is not there. We got the next 5 rows. So offset n, and here limit m. So m is number of rows from the top. Okay, so that will give me a number of rows in the output. M number of rows. Offset n means it will skip n number of rows from the top. Okay, so it will skip n number of rows from top and give us m number of rows after skipping n, right?
M minus n number of rows.
No, m minus n. No.
So skip one from n.
No, here we have just limit 5, right?
Yeah.
So if we have 100 rows, but we just put limit 5, so we'll get just 5 rows only. But if I put limit 5 and offset 2, so I'm also getting the 5 rows, but skipping first 2 rows. Right? You can see. So in the output, 5 rows will be there, but we are skipping first 2 rows. So it will skip n number of rows from the top and give us m number of rows. That's it. From the top. From the top, after skipping that much number of rows. We can write like this. Okay? You can see here like that. If I put 3, so David will get skip, and then we will have one more student here. So you can see Lakshmi got added here. I hope limit and offset is clear now.
Sir, in the week 3 content, sir, they're talking about view, transactions, and references. All that, it's very difficult to understand, sir. I tried.
Transaction part is not there.
Sir?
Transaction is not there in week 3.
Sorry, I think something else. I forgot the name.
This
But
function, procedures, and triggers.
yes, sir. Lot of things are there in week 3. I watched the lectures, but it's very difficult to understand.
Yeah, see, whatever we have discussed, that is still lecture 3.4. Okay.
Yes, sir.
Lecture
This is
3. Lecture 3.5 is basically function, triggers, and procedures, right? So for that, I have already recorded a tutorial, already a part of content. You can just watch that tutorial. That is enough. We are not going to have SQL question based on the triggers and functions. Okay, procedure.
Got it. Sir,
Sir?
from week 4, from week 4 onwards, except for week 7, we won't have any programming assignments.
No,
sir?
no, only week 2, 3, and 7. That's it.
Got it.
Sir, could you please repeat this offset part? I just lost my network. I'm so sorry.
Yeah. So see, if we apply a order by clause, so this will order in descending order, ascending order by default. You can see, right? Limit will give me number of rows from the top. So limit will give me number of rows from the top. So if I put limit 5, so I will get first 5 rows from the top. But if I put offset 2, offset means what? It will skip first 2 rows, Robert and John, and then it will give us the next 5 rows. So first 2 rows, right? Then it is giving next 5 rows. So if I say this is m, this is as n, so you can see it will skip n number of rows from the top and give us m number of rows from the top after skipping, right? This is what we are saying.
Yes, sir. Thank you.
So this is about the SQL part. We'll discuss about the views concept. For functions, procedure, triggers, I have shared the link, or it's a tutorial. You can just refer to that. That is good enough for triggers. Okay, that's it. I think in the do we have that tutorial?
So in the order of execution, where will the like clause will lie?
Like is basically part of a filtering condition, right? Where clause?
Yes, sir. Yes. Yeah. Oh.
So
Sir?
like yes.
Sorry, sir. I just wanted to ask what will we cover in the next session?
Next
live
session we'll see. I don't know who is going to take. So remaining part will get covered. Okay.
Got it, sir.
I
Sir,
guess
could-
the video I have shared, that is not in the course content. It's a different case study. So you can watch the case study first, tutorial 3.1. That will help you to understand the concept of triggers. And then whatever I have shown here, that is the SQL execution of triggers, how we can execute the trigger. Okay. So you can watch that this video I have shared. Okay. Yes. Any question? Just someone is asking something. Yeah. Okay. Fine. Now, what is views, right? So, as name suggests, view here, right? So, it's a temporary table, we can say. Let's say, for example, I have a big database, right? So, I have information where we join a 3-4 table. Yeah, this one, right? Hello, I'm audible, right?
Yes, sir.
Yes, sir. Yes, sir.
So what is view here? So let's say, for example, I have executed this one. So this is giving me all the information about the student who have issued the book, right? Now, if I want to filter some record here, let's say, for example, I want to find out how many of them from CS student, right? So I need to put a where condition here, where department code equals to CS. Then I will get code equals to CS. Here we can put D dot department, right? Like that. Or if I want how many students from mechanical department, or which student is having a date of birth after this date of birth, or whose student is having the mobile number, this one. So basically, I want to deal with the student who have issued the book. So every time I need to write this query, then I need to apply the filtering or whatever the group by we want to apply, right? So what if I need to execute some particular query every time to get the data, then we filter the output. So why can we not store that query in some table here? This is what view is. So the syntax for creating view is create view. Then you have to give the view name. Let's say, for example, book issue student, book issue student, or S, for example. So create view, whatever the name you want to give, you can give that as, and then you have to put the entire SQL query inside the bracket here. Okay. So let's see. Here we have a bracket. So let's try to see. Yeah, so this will not get stored because roll number is more than once, department is more than once here, because in the table we can have only one column for a particular name, right? This is the output. That's why we have multiple column with the same name. So here what we will do, we'll put some attributes only, not all the attributes. So let's go. I just deal with the roll number.
Sir, I couldn't understand why it was not showing anything.
Yeah.
Error. What was the error, sir?
Okay. So see, this is the syntax for creating view. Create view, and view name as we have to put, and whatever the SQL query, whatever the output you want to store, that you have to specify. But if I execute this one, see the error, roll number specified more than once. It means what? In the output, we have roll number column twice, department code twice, member number twice, right? We cannot have two columns in the table like that. This is the output of the query, not the table, right? But if I try to store in the table, it will throw an error, right?
Got it, sir. Got it.
So that's why what we are doing, instead of storing entire data, we are simply storing a roll number, because from roll number I will get all the information, department code, and then we have, let's say, for example,
Mobile number.
Yeah, mobile number, any attribute. So what are the attribute you want to store, that you can do that. Now if I try to execute department, this one, roll number from student table, right? Now see, the output of this SQL query will get stored in the table. You can see create view successfully, right? Now I can see this simple as table select star from book issue.
Sir,
Huh?
you did not specify the mobile number taken from this table, but it did not
Because
show
mobile
the.
number is only once in the output.
Okay, so it did not confuse from the.
Yeah.
It understood.
Because we have multiple roll numbers, multiple department number, and member numbers, then it will get confused, right?
Okay.
So select star from whatever the view name we have given. You can see we got that output, right? We have stored the output of this one inside the table here.
Sir, but this book issues, it won't be part of our main database in the physical structure. It won't be a part, no, sir. I just want
This book issue table, right? This new view.
Yes.
Yeah, this will be a temporary table. So this is basically what? We are not storing the output of SQL query. We are storing the SQL query. So whenever we are executing this one, database is executing this query. Right?
Yes.
Because there might be possibility that a few students may remove from the members table, right? In that case, the number of rows or output will get changed. So this is not calling the table, even though we call the temporary table because we can perform all the operations. But what is happening? We're again executing this query only, right? So you can see on the right side, we have a, can you see on the right side, my cursor here?
Yes.
So LIS, right? In LIS, if you scroll down, you can see tables, you can scroll down, you can see triggers, types, and views. Now you can see book issue is one of the views here, right? You can see columns, you can see rules, you can apply triggers here as well. So previously it was not there. You can check your database as well. So now we have created, now it got stored in the views, right? You can see the columns as well. So basically when we are executing, it is calling the query, we can say. Because if I remove some data from the student table, let's say for example, I have removed 5 records from the student table. And so all of them have issued the book. It means what? The output is getting changed here, right? So that will get reflected here. That is basically a dynamic in nature. I think in the lecture, professor has mentioned, right? Dynamic in nature.
Sir, suppose if we are updating or deleting something and we reference the view instead of the actual table, what will happen, sir?
That will get updated automatically.
So it will update.
Yeah. So let's say, for example, if I issue, we have 20 rows, and if I remove these 5 roll numbers from the database, but if I still execute this one, all 5 rows will get removed here. So we are not storing a data, we are storing the SQL query here. Right?
Got it.
Yeah.
So this AS we used to use for creating aliases. So it is functioning differently over here, right?
View or what? As
This
yeah,
AS.
this one. Yes, yes. The alias is for book issue table, and whatever the output we got, we are going to store it here in this one. So alias, like we are renaming this one, right? So you can say instead of this one, we are renaming this one, right?
Oh, yeah, got it.
So that's what I said. It is not storing a data, it is storing the query, right? Because if I do any changes in roll number or student or department or member table or book issue table, the output will get changed. So the table data should get changed here, right? That's what book issue, that is what view is, dynamic in nature. Whatever the changes we do in the main database, if it is affecting the SQL query, that will get reflected here. Okay.
So, quick question. This select star, select all from book issues _s. If I look at that command, select is normally in most cases we used it for a database. Typically select star from table, right? Now in this case we are using a view. So select is able to differentiate between a view and a table, right? That's my understanding.
Yeah, so basically it's a temporary table we are saying.
Okay, temporary table. Because my question is, if I supposedly we had a same name, a table with the same name already as a view name, then there's a clash between the table and the view. Book issue _s.
So we cannot create the view with the same table name here. That's why I put _s, right?
Sure. Okay.
So you can see if I just copy this query, and if I just put a bracket here, if I execute this one, Select star from select subquery in from must have an alias. Yeah, as S. So you can see we're getting the same output here, right?
Okay.
So this is basically a view here.
Okay. So view itself is a temporary table.
Temporary table, or we are simply storing the SQL query here, right? Instead of using this.
And how long this is temporary? So when you say, for example, we close admin or this PG admin, will it automatically close?
It will be
the view?
there.
No,
Views
it
will be there.
It will be there.
Yeah, unless we remove that. Okay.
Sure.
So there is two things. First, this is view. This is dynamic in nature, but there might be possibility, right? So I want to store the output of this in some view, but I don't want that output to get updated when something is updated, right? So even if I delete the rows of this information of this 5 student, I still want their information in my view, right? We might want that functionality as well, right? So we don't want that dynamic in nature. So for that purpose, we use materialize view. Materialize. I need to check this, but materialize view, something materialize view here. So create materialize view, and then we can do that here. Okay, simple. That's it.
So, sir, could you please reiterate what is the difference between materialize view and view?
Materialized view. Yeah, it is ZE. Yeah, sorry. I'm just checking. If not, yes, it's Z here, I guess. Yeah, it's a materialized view. Okay, that's it. The difference between the simple view and materialized view is that, let's say I create a materialized view here as well.
Sir,
Huh?
I have a request. We have another session of MLF. So can we do this in next session, please?
No, I will just explaining this one. That's it from my side then. Rest we
Okay,
get
okay.
in next session.
Okay, sir. Thank you.
So you can see book issue underscore yum. So this is basically what materialized view. Right? Now both are the same thing, same query. But if I remove some information from department table or student table, right? Or if I remove the record in which we have this book issue. Let's say, for example, I have removed this 5 student record from the student table. So if I execute this one, so this record will also get removed from the book issue underscore S.
Yes.
But if you want to have this record as well in your table, in temporary table, then you can go with materialized view, right? So if I remove the 5 record, you will get the same output, right? You will all 5 records will get removed from the book issue S. But if we go for a materialized view, that 5 record will be there in the table. Okay. So let's try to remove. How can we remove a student table here? Yeah, will not do that because otherwise I need to again restore the database. So
Means
try
it won't
to
be-
yes.
Yes. It won't be affected by the changes we do in the database.
Yes. So this simple view is dynamic in nature. Whatever changes we do, it will get affected. But materialized view is basically it will not get affected. Right?
So, sir, if we update and if we use select with the materialized view, then it won't update. It won't do anything.
No. Whatever the output of SQL query will be there, that is getting stored in the materialized view. That's it. Even if we remove some record from the table, so view will get updated, but that materialized view will not get updated.
Okay, so if we do any change to the original view, materialized view already saved whatever we put.
Yes. Yeah.
Oh, got it.
Okay. So if I remove the first 5 record, so that will get reflected in the view. So view will not show the first 5 record because we removed. But materialized view will store that information about those 5 students as well. Okay.
So it's something like taking a complete database and storing and freezing it for the particular time snapshot. Is that right?
Not database, output of SQL query we can say.
Yeah. So if I want to create a complete database image which is frozen in time, it is not going to change irrespective of the future changes. I can run a query to create a copy of the database and freeze it.
Yeah,
in
you can
form
say
of a
like
view.
Output of query you can store, right?
Okay, thanks.
But let's say, for example, after a few months, you want to update that materialized view, right? Now your requirement got satisfied. Now you don't require the information of 5 students, right? Let's say, for example, generally we store the information or any employee for, let's say, 5 years. After 5 years, we don't want the information of the employee who left the organization. So in that case, we need to update the materialized view, right? So how we can do that? So there is something called refresh. I just want to refresh this book issue materialize here. So refresh. I don't think it will work. Let's try. Book issue. So book issue. Yeah. Refresh. Materialize view. I think we have. I don't know the syntax, but we can refresh this table. So then the changes will get updated here in this particular. Yeah, you can see, right? Refresh materialize view. Now the record that we have removed, that will get updated here. So it will not show those 5 records now. So whatever the query output of query will have at that point when we refresh, that will get stored in the materialized view. Are you getting what I'm saying?
Yes, sir. So it has the option whether you want to keep the record or you want to refresh the record. Right.
Yes. So this will store the data as it is. View will update. It is dynamic in nature. But let's say after 5, 6 months or 1 year, if you want to update the materialized view as well according to a latest data, then you can simply refresh that particular view like that.
And for the time being, we can keep that record. And again, if you want, it can be refreshed. Right?
Yes, yes, yes.
Sir, I have a small doubt in this line number 77 and 8. Right. The syntax you have written, create view, book issued as. So can we write it as create view as the code you have written in the parentheses?
No.
And,
This is the
and in the
syntax for
last,
creating view. So create view, then we have to put view name, then as an SQL query. This is the syntax for creating a view. This is a syntax for creating a view. Okay. So this is for syntax. So you are saying we can put as earlier, create view as.
No, the output what we are getting, we are getting it, storing it view name as. It is stored in. So suppose we write create view and this SQL query and in the last as that name. So will it work at the last?
We'll see. I don't think so. We'll try to execute this one. No, syntax error is showing, right? Showing syntax error. So we need this is not a syntax for creating a view here. So you can go with this one. Create view name, then as, then SQL query. That's it.
Okay, sir. Thank you.
Okay, so that's it from my side. We have discussed about till week 3.4, so lecture 3.4. If something is remaining, we'll cover in the assigned session. Okay, we'll inform the other instructor. They will cover that part.
Thank you, sir. Thank you.
Okay, thank you, everyone. Bye bye.
Thank you, sir. Thank you so much.